For the positive Indian Ocean dipole, we found that the central part of India, the monsoon trough region, gets more rain. But during negative Indian Ocean dipole, we find that the western part, which is usually dry, gets more rain. For example, Rajasthan and the desert region of India gets more rain during negative Indian Ocean dipole, and that happens because of the east-west circulation that develops during negative Indian Ocean dipole, and the north-south kind of circulation develops during the positive Indian Ocean dipole, give rise to more rain in the central Indian region. And if you compare that with the El Nino, El Nino doesn't have a very asymmetric response. Most part of India is dry during El Nino years. Most part of India is wet during La Nina years. However, the Indian Ocean dipole has an asymmetric response. Some regions get rain during positive Indian Ocean dipole, and the western part gets more rain during negative Indian Ocean dipole. And that happens, as I said, because of the east-west circulation that happens during negative phase, and the north-south circulation that happens during the positive phase. The monsoon winds strengthen and the monsoon trough, giving rise to more rain in central India, whereas the east-west gradient and the circulations related to that give rise to more rain over the Western Ghat region and the Rajasthan desert region. It also has large impact on Australia, Indonesia, and maritime continents. So, some studies suggest that the 2006 IOD alone caused 8 billion Australian dollar loss in crop yields. Some part of Kenya, Tanzania got flooded, and like 1 million people were displaced for just one event, 2006 event. Whereas Indonesia suffered from drier condition, less crop yield, and also forest fire. Usually when we have positive Indian Ocean dipole in Indonesia, at least in the western side of Indonesia gets forest fire and droughts. This is a kind of plot which is showing some of the seas in the Indonesian region are also influenced by both El Nino, La Nina state and positive and negative Indian Ocean state. When they are happening together, the influence is very strong. But if they are happening independently, for example, if you have El Nino or La Nina happening only in the Pacific but nothing in the Indian Ocean, then the eastern side of Indonesia will be influenced by the El Nino or La Nina. Similarly, if El Nino or La Nina is not happening in the tropical Pacific, only IOD is happening in the Indian Ocean, then the western side of Indonesia will have stronger influence coming from the Indian Ocean. And one of that we found in our study for understanding stream flows in Citaram River, which is providing water to several cities including Jakarta, and it is one of the big river in western Java and is influential to socio-economy in the region. What we found that the stream flow in Citaram River is related to both Indian Ocean dipole and ENSO, El Nino Southern Oscillation. If you have positive Indian Ocean dipole, then the river discharge, the stream flow is low in Citaram River, and also if El Nino river discharge is low, and if they are happening together, those are very low stream flow years. So river water will be very less and affecting many things in several parts of West Java. Similarly, if you have La Nina and negative Indian Ocean dipole, the river flow will be much higher, so many parts will get flooded during La Nina and negative Indian Ocean dipole. So we found that the river discharge, river stream flow, water management can be managed to some extent if you have advanced information of El Nino, La Nina and the Indian Ocean dipole. Based on that, we can develop early warning system for the river basin and can help society in that way. The Indian Ocean dipole also influenced, like El Nino, the ecosystem, especially in Java Sumatra region. If you have a positive Indian Ocean dipole, the winds are strong, southwesterlies are strong, southeasterlies are strong. That will produce kind of strong upwelling in the Java Sumatra region, and upwelling will bring nutrient rich water to the surface. So, that is why the primary productivity will be higher, and this is what is observed from the chlorophyll maps during the positive Indian Ocean dipole of September 2015. This is the peak time of IOD, and if you compare that with a negative Indian Ocean dipole that happened in September 2016, you can see very less primary productivity happening around Java Sumatra region, because the winds are now opposite. So, it is causing less upwelling or sometimes downwelling. So, that is not bringing nutrient rich water to the surface. So, during negative IOD years, it is not good for the ecosystem in the Java Sumatra region and also fishery for the Java Sumatra region. So, if you combine the information coming from the positive negative Indian Ocean dipole, the monsoon also affects the upwelling in that region, and the El Nino, we can develop a good prediction system for ecosystem and fishery, because primary productivity is one indicator for the fishery in that region, ecosystem and fishery in that region. So, in that sense, we can produce a good prediction system that can predict ecosystem and fishery in the Java Sumatra region. Many studies try to say that Indian Ocean dipole is strongly influenced by ENSO. It is true that some of the years when ENSO happens, and because of their proximity and because of the water circulation, combined water circulation, we can have ENSO influence on the Indian Ocean. But similarly, Indian Ocean can also influence the ENSO. In one of my studies with Professor Yamagata, we showed that the Indian Ocean dipole can influence southern oscillation. And then in this study, Izumo et al., we found that the ENSO predictability can be influenced by IOD, and by using just IOD information, we can predict ENSO 2 years ahead, because the cycle of the Indian Ocean dipole influences the cycle of ENSO in the tropical Pacific. Like El Nino southern oscillation, we also have strong teleconnections of Indian Ocean dipole. Basically, Indian Ocean dipole impact is strong in the Indian Ocean rim countries, Indonesia, Australia, India, Africa. They all get strongly influenced by the Indian Ocean dipole. But besides that, the atmospheric teleconnection I showed you in my previous lecture can bring information from the tropical Indian Ocean to the higher latitude. So, if you have Indian Ocean dipole, especially positive Indian Ocean dipole, then we expect more rain and warm condition over Argentina, northern Argentina and southern Brazil, the La Plata region here. We found that the atmospheric teleconnection can bring information from the tropical Indian Ocean and can influence the rainfall and temperature over Southern America. Similarly, Indian Ocean dipole can influence the summertime conditions over Europe, especially Western Europe, and also East Asia and Japan. And that happens through these kind of atmospheric teleconnections. These are the Rossby waves propagating at 200 hectopascal during October, November of IOD years, positive IOD years in this case. So, these are the meridional wind that shows how the wave propagate from the tropical Indian Ocean all the way all around the globe to complete and the cycle. 200 hectopascal is the upper part of the troposphere, and these waves propagate. We have two wave trains. One is going into the southern part of South America, the other one is going to the northern part of South America. There is another wave in the northern hemisphere propagating all the way and coming back to Europe and also Middle East. Talking about the Europe, we found that the circumglobal wave, rust wave that propagate because of the IOD can cause, especially for positive Indian-Ocean dipole, whenever cool temperature of Java, Sumatra, warm temperature of Africa, that kind of condition can lead to atmospheric disturbance and teleconnection, leading to like heat waves over Europe. We found several heat waves, especially over Western Europe, are related. The blocking high, the heat waves happened in 2007 and 2010 are related to the Indian Ocean dipole, because you have convection there, the rainfall convection there, that can cause atmospheric disturbance, and the wave can propagate all through the globe to cause disturbances over Europe. And this is the other case when the wave propagate in the southern hemisphere, causing more rain over La Plata region, the Brazil and Argentina basin there, causing more rain during September, October, November, just before the summer there, spring season there. We also found that the summertime temperature over Japan is largely influenced by the Indian Ocean dipole, in addition to the La Nina. If you have positive Indian Ocean dipole and La Nina, we found that like 2010 we had this situation when we have positive Indian Ocean dipole and the La Nina, and that led to heat waves over Japan through that kind of triangular teleconnections. So, if you have positive Indian Ocean dipole, Sumatra region is cold, wind diverges from there, they converge over Philippines, and again cause a divergence over Japan and East Asia. The other way is like we have divergence there, they converge to the monsoon trough, and monsoon trough, monsoon rain will cause rust wave or expansion of the high pressure system, and that signal will cause drier and warmer condition over Europe, and that signal propagate to East Asia and Japan through the rust wave there. So, that is how two ways, and the Sumatra region upwelling and the positive Indian Ocean dipole can influence the warm summer condition over Japan. So, whenever you have positive Indian Ocean dipole, we have warmer condition over East Asia and Japan suffered from serious heat related diseases, heat strokes, especially if you have positive Indian Ocean dipole and La Nina happening together, like what happened in 2007 and 2010. And Japan suffered from serious heat waves, and it's also happening in present years. In another study, we found that Doi et al. Found that the convection happening over Somali region during positive Indian Ocean dipole, especially towards the late season during October, November and December. For some example, in the case of 2019 and 20, positive Indian Ocean dipole caused warmer temperature in winter time over southern Japan, and the predictability of that winter time temperature was coming from the Indian Ocean dipole. So, Indian Ocean dipole influence can be seen in other parts of the globe outside of the Indian Ocean rim countries. The consecutive positive Indian Ocean dipole, like consecutive La Ninas, are seen in recent decades. Especially we find that 2007, 2008, 2009, 3 consecutive positive Indian Ocean happened in the Indian Ocean. So, if this kind of thing happens in the future more frequently, more positive Indian Ocean dipole, then the influence coming from the Indian Ocean will be very strong, not only to the Indian Ocean rim countries, but also countries all over the world.